All right, so I asked you guys to do this in notes. Evaluate the expression. Evaluate the expression if x equals -3. Evaluate the expression. What does that mean, evaluate the expression when x equals -3? Well, I know what you mean. I don't like the word solve. Evaluate is the verb. It means put it in and find the value. Very good. Evaluate is value. Find the value. So work it out, so to speak. All right. What did you get?
I got -5 over 0.
-5 over 0. Good. I heard no solution. And which is not, shall we say, incorrect necessarily, but I have a different word I want you to use. Undefined. Okay, undefined. Here's the saying, ladies and gentlemen. When the 0 is under, it's undefined. Okay? When the 0 is under, it's undefined. And that's really, really important for us. Especially right now, we're going to be talking about rational expressions. Rational means what? Ratio. Good. Ratio also is a fraction. Very good. So I like to say rational fractional because it rhymes, and I really like anything rhyming or alliterative. Okay. So rational fractional. We're going to do exactly what we've been doing all this week. Factoring, but now I've turned it into rational expressions. Fractional expressions that we're just going to factor, and cancel. Okay? And the reason I want to talk about why this becomes undefined is because when I have a rational expression, this is an example of a rational expression. There's an x in the denominator. Okay? Anytime there's an x in the denominator, I have certain numbers that cause this to happen. So in this case, for this function, for this rational expression, I cannot use this number for x. I cannot use -3. Why can't I use -3? Because it's undefined. However, every other number I could possibly think of would work just fine in this expression, okay? This is called domain. All right? X cannot equal 3 is the domain of this. Well, the domain is everything else, okay? All real numbers except x equals 3. Right, thank you, -3. And that's something I want you to be thinking about. It's not super relevant today or tomorrow, but we are going to have to talk about that when we go to graphing. So I like to point that out. In this book for this section right now, we don't have to worry about explicitly stating that x is not allowed to be -3. We're just going to make the assumption that we already know that, and that's already assumed, okay? And that's sort of really important for us when we're simplifying right now. Later, we'll worry about it when we're graphing because it makes some really interesting graphical things happen. Okay, rational fractional expressions. There was something else I wanted to talk about, and I don't remember. Maybe it'll come up when I get there. All right, here we go. Oh, I remember. Stop. Okay, here it is. Let me ask you a question. I get a lot of students that say, we're going to simplify rational expressions. And so simplifying a rational expression is the same as simplifying a fraction. I can take like 12 over, 32. Okay? Now, if we wanted to reduce 12 over 32, the actual thing that we do is we look for their greatest common factor. Okay? And so what happens is we would sort of break these apart into their greatest common factor, maybe 4 times 3, and then on the bottom, 4 times, what was their, 4 times 8, that's fine, okay. I'm thinking of 9, okay, I can multiply. And when they have that greatest common factor, then I can, they reduce. because what I have here is a fraction. 4 over 4 times 3 over 8. And what does 4 over 4, 4 divided by 4, reduce to? 1. So these reduce to 1s, and I get this lovely fraction 3s. Now that's a really long and involved drawn-out explanation of reducing fractions. We're doing the exact same thing. My question to you is, when you see something like x minus 2 over x plus 3, can you just cross off the x's and say it's negative 2/3?
Yeah. No.
So I love asking this question because I get yeses and nos. It's very mixed. We want to just cross crap off all the time, but it doesn't work, okay? So here's how you prove that, ladies and gentlemen. If you ever had a question of, can I just cross these off? There's x on top and bottom. Doesn't it work just like the 4s, okay? Here's how you test it. Hey, let's let x equal 7 and see what happens. So 7 minus 2 over 7 plus, well, maybe this is a big bad choice, but whatever. We'll see what happens here. I know this fraction turns out to be 5 over 10. That's a true statement, right? Okay. That's a true statement, right? Okay. So our question then, is it the same if we just cross off the 7s as negative 2 over 3? No, totally false, right? All right. Plugging in numbers and testing things out is a great strategy when you're like, I don't know if I could do this. Try it. Go back to numbers, okay? Because this was pretty conclusive proof that I can't just cross off 7s, okay? You are allowed to cross things off when it's all connected with multiplication. Multiplication is the key, not addition and subtraction, okay? So very different, and that's what we want to do today with rational expressions. We learned all these ways to factor. We're going to factor, okay? Example 1, simplify the rational expression. Simplify the rational expression. Rational fractional. Letter A is hopefully easy for you. We don't really have any questions on that. Is there any addition or subtraction problem here? No, it's everything connected with multiplication. And because of that, if I wanted to, I could expand it, but it's not necessary because I bet you know what to do here. We can reduce. The 9 on top and the 9 on bottom reduce. It's not 0, it's 1. I want to make sure we all know that 9 divided by 9 is 1. And so we're left with negative 1 on top and 2x squared y in the denominator. That was easy, right? Okay, so what's the difference between A and B and C? Addition and subtraction. Adding and subtracting, you never knew this growing up, but adding and subtracting is actually makes everything harder. Multiplication and division is the easy part. Think about it. Adding fractions, got to get a common denominator, then you got to combine them, right? That's hard. Multiplying fractions, straight across. Super easy. Okay? So here we go. We need to factor. Factor first. Alliteration. Factor first. Factor, factor, factor. All right, what can we factor out of the numerator? An x. Mm-hmm. If I take out an x, what's left behind?
X plus 2.
All right, and in the denominator. Very good. This is difference of squares, so we can double bubble that. X times x is x squared, positive 4 and negative 4. Now, because we were able to factor, we have x times this bubble and one bubble times another bubble. Everything is connected now by multiplication. We're in factored form, so now things reduce. What's x plus 4 divided by x plus 4? 1. It reduces to 1s. And what are we left with? That's it. Good. What is x not allowed to be? 4. Yeah. Why?
Because it'll cancel the bottom.
Yeah, because if you plug in 4, 4 minus 4 is 0. That's not allowed, right? Okay. You don't actually have to state that, but I'm going to point it out every time. All right. 5n squared plus 6n minus 8 over 10n squared minus 3n minus 4. Again, can I just cross crap off? No, you cannot. Just jump it out of your hands today. All right. We cannot just cross stuff off. Addition and subtraction are unbreakable bonds. We have to factor. So, this is a trinomial. What should we try to do? Try to factor. Double bubble. All right. First times first has to be 5n squared. What times what is 5n squared? 5n times 1n. Very good. And then last times last has to be negative 8. What times what is negative 8? Negative 4 and positive 2. All right. Oh, that was an excellent. Negative 4 and positive 2. And there's some other choices in there. How do you know if you did this right?
Rainbow.
You must check the rainbow. All right. So write it in your notes. This is the reminder. Oh, yeah, I need to check the rainbow. When I check the rainbow, I'm going to get 10n and then a negative 4n. And 10n minus 4n gives me that 6n. So I know I did that correctly. All right. Make the notation. It's a reminder for yourself. So many students get wrapped up in, oh, it has to be negative 8 and add to 6. That doesn't work. Okay. All the time. Doesn't work. On the bottom, again, it's a trinomial. What times what is 10n squared? 5 and what did you say? Okay. And then last times last has to be negative 4. I'm hearing negative 4 and positive 1. We got negative 2 and positive 2. Negative 4 and positive 1. You guys are super fast. It's really awesome. Let me see. I got to check my rainbow here. We got 5n minus 8n is negative 3n. So we did it perfectly. Good job. Check the rainbow. Okay. Now that we're factored, can we pop those bubbles? Yes. Yes, since we're connected by multiplication, we can reduce now. And I like to say pop the bubbles because it helps you remember they have to be in bubbles. And then you can pop them. Okay? And 5n minus 4 over 5n minus 4 reduces to 1. And we're left with? Over 2n plus 1. Oh, very good. Hey, tricky question. What is n not allowed to be? One half or negative 1 half?
Negative 1 half.
Negative 1 half. Very good. N cannot equal negative 1 half. You see that? What happens when you plug in negative 1 half? 0 in the denominator. Undefined. Okay. Very good. All right. I have just 2 more. It seems like a lot, but I'm just trying to get all the different kinds of factoring in. Okay? And E seems easy, but. All right, we got x cubed minus y cubed over x squared plus xy plus 2xy plus 2y? Okay.
Oh, the top.
It's all addition of them, I guess. All right. X cubed minus y cubed. What's that called? Difference of cubes. Very good. We did that yesterday. And by the way, if you have your test corrections and homework that you took home, please turn it into the basket. All right. Difference of cubes. How does difference of cubes factor? Small bubble, big bubble. Very good. Tell me about the signs. Keep the sign, change the sign. Always positive. Very good. And then what is being cubed? X minus y. And then what? Square it, multiply them together, and square it. Square the first, multiply them together, and square the last. Very good. Now, what do you notice about the denominator? Split, yeah, divide and conquer, yeah. So, greatest common factor, this is a factor by grouping, is what it's called. Factor by grouping works for any even number of terms. I got a fun worksheet last year, and it had like 8 terms on it, and the students factored. I was like, holy crap. It didn't occur to me. But yes, divided it into 4 and 4, and then they split that up and split that up and just kept taking GCFs. It was really cool. All right. So we're going to split this up, and I can take out a GCF in front. What can we take out in front? An X. All right, I'm going to take out an X. What's left behind? Oh, X plus Y. Very good. That's what you said. And then in the back, we can take out a GCF. What do we have? Positive 2, and it leaves behind an X plus Y. And then we notice that they have another common factor. So we take out that GCF again, and what's left behind? You know, this was, damn it, I hate when these don't work out like I expect them to. I have a typo. This was supposed to be sum of cubes.
That was right.
So much more.
So much, yeah. Yeah, sorry about that. So what's the signs for sum of cubes?
Yeah.
Positive, negative, positive. Very good. Keep the sign, change the sign, always positive. Sorry about that. There was a point. It had to work. All right, so now what reduces? X plus Y. Sorry about that. I hate when I mess up. I guess you just know that I'm human too, right? X squared minus XY plus Y squared. Will this factor? No, it will not. It will never factor. Okay. Very good. I just wanted to remind you of those strategies for factoring. Now, this last one is kind of interesting. There's a couple ways I could do this, but I'm going to show you the quick way because you guys are quick. This, again, is difference of squares. What's weird about it? It's kind of backwards, right? It seems backwards. It feels backwards. So I'm going to leave it as it is. I'm going to factor just like we have. First times first has to be the 4. What times what is 4? 2 and 2. And last times last has to be negative x squared. What's that? Positive x and negative x. Very good. Now, factoring the denominator. X times x is x squared. What times what is negative 6? Very good. Positive 3 and a negative 2. Very, very good. Now, does anything cancel?
Yeah.
2 and negative.
No.
Wait, I don't know.
No, I did this question. I'm confused. Okay. So what? They look close, right? These guys right here. They're very, very similar, right? Okay. All right. So these, we have a positive x compared to a negative x. We have a positive 2 compared to a negative 2. These are called opposite factors. They are exactly opposite. If you wanted to rearrange this and take out the negative 1s, then you would see that there'd be this extra negative 1 hanging out. So you could have done that and then factored further, and there's this negative 1 hanging out in front. That's always an option, but I would just say if you recognize opposite factors, they're exactly opposite. They reduce what do they leave behind? A negative 1. Because they're opposites. 1 is a, right? So that's where that negative 1 comes from right there. So what I'm going to do then is just put this negative 1 out in front. And 2 plus x, you could write x plus 2, that's the same thing, over x plus 3. What is x not allowed to be? Cannot be negative 3. Very good. Okay. Opposite factors, cancels and leaves behind a negative 1. You got it? Cool. You guys have a worksheet.